Hi guys, in this video we would be solving a DSA problem which was recently asked in Atlassian interview. The question says that we have an array called nums and we also have some queries to be performed. So for each query we have to find the weighted sum from left index to the right index. Example, here left index is 3, right index is 5. It means that I have to find the weighted sum from index 3 to 5, that is for this range. And how to calculate the weighted sum? It is given over here, this particular part. That is, I will multiply the first element with 1, multiply by second element by 2, and multiply the third element by 3. So the total answer of this would be 34. So this is how we calculate the weighted sum for each queries. And talking about the constraint, there can be at max 10 to the power 5 queries, and for the nums also the size of the nums can be at max 10 to the power 5. And yes, so we have to build this particular array and return this. So obviously, if I have to build this array, I have to iterate through the queries array, right? So the time complexity would be at least, at minimum, it would be big O of Q. And for each query, if I do the brute force way, that is iterate from L to R, then the time complexity would be big O of Q into N, which would obviously give TLE. So I have to somehow remove or eliminate this particular n. In other words, I have to find the weighted sum from L to R in big O of 1. So this is the requirement in order to solve this problem without encountering TLE. Okay, so forget about the weighted sum for a moment and just think about the normal sum. By normal sum, I mean that let's say if this is the range, the normal sum would be 8 plus 7 plus 4, which is 19. Okay, so let's think about how to calculate a normal sum from index 3 to index 5 in O of 1. So we already know this technique, that is, if I know the total sum from index 0 to index 5, and if I subtract the sum from index 0 to index 2, the remaining sum is the sum that we need, right? So in other words, I'll say that prefix sum till index 5 minus prefix sum till in till index L minus 1, or you can say it's 2. Okay, so that is this particular part I am subtracting, so the remaining is the sum that we need. So this was for normal sum. So what I thought was, while solving this problem, that is, maybe in order to calculate the weighted sum we can use the same technique. Okay, so I thought this way, so I tried the same technique over here. That is, so this is the same array, and this is the range for which I have to find the weighted sum, that is this particular part. So I tried the technique that we discussed. So I calculated the total weighted sum from index 0 to index 5, which is present over here, and I also calculated the weighted sum from index 0 to index 2, which is present over here, and subtracted that from the weighted sum from index 0 to index 5. And we know the weighted sum is calculated like this, that is 6 will be, the first element would be multiplied by 1, second element will be multiplied by 2, third element will be multiplied by 3. Hence I've done like this. Okay, so I did this, and when we subtract both of them, this particular part and this particular part would cancel each other, and the remaining part will be this thing. So let's write that over here. So this is what we got: 8 into 4 plus 7 into 5 plus 4 into 6. Okay, this is what we got. But what we wanted was this element should be multiplied by 1, this should be multiplied by 2, and this should be multiplied by 3, right? So let's write that 8 should be multiplied by 1, 7 should be multiplied by 2, and 4 should be multiplied by 3. Now this is what I got and this is what I wanted. Now observe the difference. All the elements are same, right? Only thing that has changed is the multiplication factor. Okay, so in the result that we got, the multiplication factor is higher. It means that the result, this particular part, is higher than what is needed. Okay, so I have to subtract something in order to get the actual wanted answer. So observe the difference of the multiplication factor. The difference between 1 and 4 is 3. Difference between 5 and 2 is also 3. Difference between 6 and 3 is also 3. So what I thought was, let's eliminate the difference. That is, 8 is present 3 times more in the above part. Similarly, 7 is also present 3 times more in the above part, and 4 is also present 3 times more in the above part. Okay, so this is what we can subtract, right? And let's simplify this equation by taking minus 3 common. Okay, so let's take minus 3 common. So the answer would be minus 3 common, right? So 8 plus 7 plus 4. So this is how the new subtracted value would look like. And what is this 8 plus 7 plus 4? This is nothing but the summation, the normal summation from the for the range L to R, right? So let's write that again, into normal summation, that is prefix sum from L to R. And what is this 3? What is this 3? 3 is nothing but index 3, which is L, right? This is L, this is R. So this is what is 3. So here we'll remove this 3 and put that over here, right? So the formula that we got is, first we have to calculate the total weighted sum from index 0 to index 5 and remove the weighted sum from index 0 to index L minus 1, and whatever answer that we got from that, I have to reduce this much amount in order to get the actual value. Okay, I hope you understood this part. If you haven't, please try out for other queries as well, okay, on your own. Now let's check out the code. So this is the array that we were working on, and these are the queries. I have defined one function which will return me this array, and finally I have logged that array out over here. So this function, in this function, I am constructing the result array, which will be of size m, and m is the size of the queries. And we also need the prefix sum, right? Over here, as you can see, we need this prefix sum, right? So I am building the prefix sum array, and I am also building the weighted prefix sum array over here using this for loop. So prefix sum of I would be prefix sum of I minus 1 plus the current element, and weighted prefix sum of I would be weighted prefix sum of I minus 1 plus I plus 1 into nums of I. Okay, if you don't know, then like this. So weighted prefix sum of index 1, let's say I have to calculate weighted prefix sum of index 1. So it would be weighted prefix sum of index 0, that is, this is 6 plus I plus 1. So here I is equals to 1. So 1 plus 1 is 2 into the current element. So this is what I have written, I plus 1 into the current element. And then I'm going for each query, and each query will have L and R. So I am just using that formula that we discussed. Using this formula, I am calculating the value and putting that into result of I. And I am also checking for the index out of bound condition, that is, if L minus 1 goes out of bounds, in that case I am just using this formula, that is, this particular part will be removed, right, because it will be 0, and this particular part will also be removed because it will be 0. Hence this particular part is used when index is out of bounds or L minus 1 is out of bounds. And after that I am just returning the result, and finally we are logging that result over here. So let's check whether answer is correct or not. So answer that we should get is 34, 113 and 38. And yes, we are getting the same answer. So I hope you understood the explanation and the code. If you still have any doubt, then please comment. I'll try to answer. Thank you.